Good afternoon, this is Schweitzer, and we're going to do a little video I would call dissecting a velocity time graph. Now, a velocity time graph is one of the two super important graphs that we need to be familiar with. Now, again, these are just things that you don't want to memorize. You want to be able to just go through a process of sort of reacclimating yourself to the graph to know, okay, what does this mean now? What does that mean? You can't expect to just jump to a graph and immediately know everything. All you're going to do is get the velocity graph and the position graph kind of crisscrossed. So whenever you see a graph, you gotta go through a diagnostic process. Okay, and it depends on where you're at as far as how much you gotta do. But this is a good review of just how this graph works. And this is some thought process that will go through my brain immediately as I see a graph. And if I don't go through this process when I look at a graph, then I'm going to start getting things mixed up. So what are the units of the slope in the area? Okay, and what do they mean? So this might be all it takes to get you re-functioning on this graph. So it's velocity on this side, okay, and it's time on this side. So the units in this thing are going to be meter. So the slope, okay, is where we divide the two x and y. So it's going to be, slope is meters per second, and we're going to divide this guy by seconds. When you multiply the fractions out, you get meters per second times the reciprocal, which is 1 over seconds, equals meters per second squared. All right, so the slope, we should be aware of that guy, is acceleration. Okay, and the slope represents acceleration. Area in the curve is where we're going to multiply. Now, on the position time graph, the area really didn't end up meaning much, but the area under this guy does mean quite a bit. It's going to be meters per second now, and we're going to remember we're going to multiply them together, just times seconds. All right, these cancel, and we get meters. So this represents the distance traveled. Okay, and we'll talk maybe a little bit more about that, what that means. Okay, what does a positive velocity mean? So that's anything that we're traveling in this direction. This is all the positives over here. This is all the negatives here. It's a little different than the position time graph. This really, again, is looking at just traveling down a line. Okay, so if this is the 0 reference mark, then this is, up and down a line and to the right. So we're going to say from Hortonville to New London to Appleton. So Appleton over here. So that's kind of where we live. This is kind of the layout. And if we have a positive velocity, let's say, then we would be traveling towards New London. So anytime we're on this top of the graph, we would be going to the right. Anytime we're on this top of the graph, we're going to the left. The bottom part of the graph, we're going to the left. So that's it. This is simply moving to the right. This is moving to the left. And it's really important to mark out that this guy here is 0 right there. All right, what does a flat line represent? Okay, so in the position time graph, a flat line represented no change of position. So flat line represents 0, okay, well 0 slope, okay. So here a flat line represents 0 acceleration. 0 acceleration. Or it means a constant velocity. Okay, that's important. Okay, so so let's take a line for example here, and we could now this one here we don't even really have to start with 0, I guess, but we could start with 0. I mean we're traveling at 0 velocity, and we accelerate up. I don't want to do that. Let's do a line. Okay, so we slowly start accelerating towards New London. Okay, maybe we're leaving town. Then, so then we hold our speed at like this. Then we leave town. We we get on the highway a little bit, and we pick up speed a little more, and we hold this speed. All right, and then here we go. So how do we stop? So in this case, we go from, we could do here, because you go for, let's say, what does this mean here? All right, so here we start at 0, maybe we go to 5 meters per second. We hold 5 meters per second, so we're still going 5 meters per second, and you jump up to 15 meters per second. We hold 15 meters per second, 15 meters per second. How do we stop? Well, stop, you have to go to 0 velocity, which is right here. So all we gotta do is right there. Okay. All right. So how do you turn around? Okay. So in this case, we're traveling. Everything is positive velocity, so everything is heading towards New London. We may be slowing down, but we're still moving towards New London as we approach 0 velocity. All right. How do we turn around? Well, literally to turn around, okay, so I would need to, well, I mean, I could do it this way. Let's grab okay. Before you can turn around on a linear line, well, typically you'd need, you need to stop first. So we're going to, let's stop. Now, a person could get to New London, let's say they're by the Quick Trip New London, and they slow down to a stop. All right, so they could choose to stay there a little while, like that, and then they could turn around and start going back the other way. This is how you turn around, okay? So this person would now be going the other direction. If let's say you drop someone off, and person B turns around, heads back to New London, and person A keeps on going. So at this point, they say goodbye. This guy keeps going. So in this situation, this particular kid here is still, has a positive velocity. This person here, kid A, is still traveling away from your London. Kid B turned around and went back towards the Hortonville area. Okay. So how do you turn around? Okay. Stop, and you gotta go with negative velocity. So all these guys have negative velocity. Positive velocities. This guy's the only spot where we have a negative velocity. It's important to realize that whenever we are, we talked about this during the position time graph. How do you speed up? Okay, how do you get going faster? Speed up. Well, really, it'd be increasing your velocity. So anytime you have of course, a positive velocity and a positive acceleration, or a negative velocity and a negative acceleration, we would be speeding up. So let's just say, for example, right here, this line between here, we have a positive velocity, and my slope, because I'm on the top side of the graph, all these guys are positive velocities. And by a positive slope, which represents acceleration, I have a positive acceleration. So I'm just going from I'm speeding up here. We're from 5 to 15. Okay. Um, how do you know? Um, how do you know if you have returned home? Okay. So this gets down to distance traveled. Let's talk about that for a moment. It's pretty straightforward, but they're going to have some very specific questions that they're going to want to ask you on this particular concept, and you got to be ready to look at these. All right. So let's just kind of grab something quickly here and see what we got. All right. So a person travels towards New London. They pick up their acceleration to a certain velocity. They hold that velocity all the way to New London-ish area. Then they slow down to a stop, drop a friend off at Quick Trip, and then they wait a few moments and start accelerating back towards their, the same road, and then they start traveling back. So they're heading back towards Hortonville. Okay. So in this situation, how do we know when we've returned home? Okay, you should be aware that how the area of the curve works and how problems are going to work out. Okay, so area in the curve is not going to be super difficult. This is going to be velocity. This is time on this guy, and they're going to want you to compare shapes, really. So here we have a triangle. Here we have a triangle. So they're going to want you just to do the math in this. Now, of course, to get a square, it's just going to be length times width. Okay, so you can do that math pretty easy, and then just cut it in half for a triangle. So we're going to look when you're traveling with a positive velocity, which all these guys are, then you're accruing distance traveled, and the area in the curve is the distance traveled. So you guys just, when we're going home, you would just need to compare your shapes. And it just becomes a little bit of a geometry problem here. And we would only compare between your line and the origin line. So I have, for example, this line right here. That's good. This line right here this would maybe cancel with this one. And then you'd say, okay, well, this piece here could cancel out with this piece here. And now I just need to go home. And they're going to use something with a very similar slope so they can very easily match up these triangles. This guy check, this guy's check. Now at this point in time, I've slowed down to a stop and I am back home on my linear line. Okay, so that's just a heads up in what we're going to do for area under the curve. And that's only working on the velocity time graph. Okay, so let's go to this next one. Let's go to an example here. Okay, again, we're asking ourselves a couple questions, a couple typical questions that might be something that a person could ask about these graphs. Okay, so what time frame did he go the fastest? Okay, that might be a question we could ask. What time frame did he stop? Okay. When did he turn around? Okay. When did he return home? Okay. Something like that. Okay. So we're trying to mix you up between the various different graphs, and it can be challenging at times for people to be able to keep the two graphs straight, but you got to remember, okay, which one's which. So when did what time frame did he go the fastest? Okay. Well, we're going at zero velocity here, so he's going this point here. He's getting faster. Holds of constant velocity. This, let's say it's like 5. Then this would be 5. So this line right here is 5. And let's just say this is like 20. So he's showing fastest in D. And of course, you want to be pausing these videos at all times and trying them out. What time frame did he stop? Well, technically he stopped either here or here. So at the start of A or the start end of E. But we're trying to trick you. Is the most common wrong answer for this guy would be B or D, because in a position time graph, B or D means you stopped. It's not B or D. All right, it's at zero velocity. When did he turn around? Bit of a trick question because he did not turn around. We don't know that they turned around. To turn around, you have to cross this line and go back the other way. When did he return home? He never returned home. This guy only has positive velocity. And if you had to, you could simply, there we go, okay, add up all the blocks. Okay. All right. Well, let's just look at the next graph. It's pretty common here is to compare two graphs. Okay. So again, the same style of questions. I have a position time graph, okay, and velocity time graph. Now these two graphs here, they simply do not match the same movement. Okay. They're two different objects. This is object A, and this is object B, undergoing completely different movement. What happens in, so A, B, C, D, A, B, C, D. Okay. So what happens in A? Okay. Well, let's describe this movement here. Okay. This individual here, what's the slope mean again? You got to recalibrate this to yourself. You just can't expect your brain to flip back and forth. You got to refigure it out. Okay, so what's the slope mean here? So the slope, okay, is meters per second. Okay, so the slope is meters per second. That's velocity. All right, area of the curve is meters times seconds means nothing. Okay, so we're all going up and down a line, and the area curve means nothing. Here, again, it's meters per second squared is my slope. Okay. So here, positive velocity is referring to slope. Here, a positive velocity is just being on this side. Okay. So this guy has a positive velocity here, zero velocity, negative velocity, and negative velocity. Okay. In this case, since the velocity is the slope, everything in this line is constant, except for at the changes here at the points. Constant velocity. So zero acceleration on really anything that we're looking at inside these lines. Okay, this has got a positive velocity. This has got a positive acceleration because acceleration is the slope. So we are in section A, we are speeding up. Okay. Other than that, the actual points on this guy, we're not really changing any velocity. Okay, I mean, it's a very abrupt change. Okay, what happens during B? So A is just holding a constant velocity. We're traveling down a line at a constant velocity in A for this guy. The velocity graph, we're going faster, 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 faster. Okay. So this guy starts out, let's say, 10 meters per second. That might be the slope. Okay. And starts out, and It starts out at 10 meters per second and ends at 10 meters per second. This case starts at 0 and picks up to a certain velocity, let's say 10. Okay, so this guy might have a constant 10 meters per second velocity. This guy starts at 0 and ends at 10, then holds 10 the whole way. What happens during B? During B, not changing position, so we stopped. Okay, this guy here just holding a velocity, constant velocity. So in B, A equals 0. Not speeding up, not slowing down. What's happening in C? Okay, well, in C, we have a negative velocity. Anytime you go from, so really the way to turn around, okay, turn around, okay, is to go from a positive velocity to a negative velocity. That's how you turn around. This is positive, this is negative. So you kind of have to come to a 0 velocity and turn around. So at this point here, we're going well, flat, we're from a positive to a negative. So we turned around here. Okay, turn around. Okay, but on this one here, what are we doing? We still have a positive velocity. We're still heading down the road towards New London with a positive velocity. We're just doing it slower. We're hitting the brakes. We're slowing down. But we're still heading towards this thing. All right. Next question. What happens when we cross this line? Okay. That's another thing. Okay. What about that point right there? For the position time graph, it's just a position. We're going down this line. We're going back this line. So this is a reference point. You could call this home. You returned home. On this one, you're back where you started. Okay. This one here just means that you've reached 0 velocity and you've stopped. Okay. What about D? D means, now at this point, you have our first opportunity for a negative velocity. Okay. I still have a negative velocity because of the slope here. But this one just means that you, in the position time graph, you turned around and now you've just gone beyond the reference point. Okay, you maybe missed your turn off and went back behind you. This one here just means you've turned around. Okay. And we would need to hold this velocity for a certain amount of time to have this area here equal this area here to return home. And I think that is a good refresher of this particular graph. Thank you.